Hi, we're going to look at this problem to do marginal analysis for a discrete demand distribution. We're looking at a hardware store and they sell Christmas trees. At the end of the season, they have to discard unsold Christmas trees. And so this is really marginal analysis because this is called a single period inventory item where the Christmas tree at the end of the season, it doesn't really have much worth, and so you cannot carry it to the next planning period. So we call these single period inventory items, and we perform marginal analysis to find the optimum quantity that we must carry, that we must buy and stock. So let's say that for this problem, the cost to buy a tree is $20 to the hardware store. And let's say that each tree that they sell is sold at a price of $80. So when you do marginal analysis, you must always compute or identify marginal loss, which is the per unit cost of having one unit too many. And you must also identify what we call a marginal profit, which is a per unit lost profit if you are short one unit. So in this problem, given that they buy each tree at $20, our marginal loss is $20, because if they buy too many and they cannot sell it, each tree is going to cost them $20, and that's the cost of having too many trees per unit. Marginal profit is the profit that they will forego or they lose because they don't have enough to sell. So what is that profit? It's that $80 selling price minus the $20 cost. So marginal profit is 60. So that's step one in doing marginal analysis. You need to identify your marginal loss and marginal profit. Step number two is to compute what I call a critical probability. And that probability is computed as I will write it, and then we will define it. It's marginal loss divided by marginal loss plus marginal profit. So for this problem, we said marginal loss is 20. Marginal loss, again in the denominator, is 20 plus marginal profit, which is 60. So that's 20 divided by 80, which is 0.25. So 0.25 is our critical probability. Let's define it. Critical probability is the probability that demand will be greater than or equal to the optimum quantity, Q star. So demand to be greater than or equal to some quantity. So what we need to do, this is step 3. So this was step 2, to identify the critical probability. And step 3 is to create the cumulative demand curve. Or demand, in this case, demand distribution, because this is discrete. So let's go ahead and finish step 3. This is our step 3 essentially that we're going to do in this column right here. And we will call this probability that demand will be greater than or equal to X. So what is the probability that demand will be greater than or equal to 50? Because here in this row, top row, demand, we're saying probability that we sell 50 units is 0.05. So what is the probability that demand will be greater than or equal to 50 units? Well, demand can be 50, 75, 100, 125, 150, 175, and 200 for this particular problem. And so probability that demand will be greater than or equal to 50, of course, is 1. This is a cumulative column. What is the probability that demand will be 75 or more? Well, it's all of this right here, all of that, which is 0.95, which is essentially 1 minus this 0.05, because the 0.05 is the probability that demand is 50. So if you subtract that from 1, then you get the probability of all the rest. So what is next one? What is the probability that demand will be 100? Will be 100. Oops, I just messed it up. 100 or more. And that would be 0.2 plus 0.3 plus 0.2 plus 0.1 plus 0.05, which essentially is 0.85. Or you can take 1 minus this 0.1 and minus this 0.05. So that gives us 0.85. So going down the column, we will finish out the cumulative demand distribution. And this one is 0.15, and of course this one is 0.05, because probability that demand will be greater than or equal to 200 is 0.05 right here. And the reason for that is because demand cannot be greater than 200, because we are told that demand distribution for this Christmas tree is here. These are the only values that demand can take. So probability that demand will be greater than 200 doesn't exist, but probability that demand is equal to 200 is 0.05. So this is our cumulative demand distribution. Now, to finish out the problem, we will recognize that our critical probability was 0.25. So we will place this 0.25 along this critical probability column. And where does it fall? 0.25 falls somewhere over here between 0.15 and 0.35. But we want demand, the 0.25 is the probability the demand will be greater than or equal to some quantity. So what is that quantity? That quantity will have to be 150. So the way you do these problems is after you create the cumulative demand distribution column, this third column right here, then you will place your critical probability, P star, and you will find that location, and then wherever it falls, the row above it will be your optimum quantity. So in this case, where price to buy is $20 and selling price is $80, the best quantity to buy of these Christmas trees for the season is 150 units if you are the hardware store manager. Now, I will stop this and we will come back to this problem in the next video to do a couple more like it.